What is time? Well, this does not have a very simple answer. It is real, but it is not so simple as we see in our everyday life. Welcome to It Science. Time is also not same for everyone. Like time for me is not same as time for you. If you are moving with speed of light, as you move faster, interpretation of time as conceived by you is different. Time on Earth, time on Sun, time on Mars, time on any other galaxy, time on the verge of black holes, these are not same. But in Newtonian mechanics, Newton thought that time is same for everyone. Like time is same. Time is a universal concept, and it is same for me. It is same for someone who is living on Mars, for example, and it is same for any other observer who is residing at any other part of galaxy. Time is not same for me who is sitting here on earth and for the person who is inside a spaceship and orbiting our planet earth. Clocks tick slower if you are moving inside a spaceship which is moving with a speed equal to half the speed of light. So if you are in that spaceship, you do not perceive time as flowing differently for you. You will feel the same as you feel like ever you do. And if someone is watching you from earth, he or she will observe that you are moving in
slow motion.
it's not only you are moving slowly, but it is the vibrations of atoms and molecules inside your body will be slower. Your aging process will be slower. Isn't that funny? In any way you can possibly measure the time will be slower. And as you approach the speed of light more and more, you will experience time slower and slower. You will not experience it. An observer who is looking at you observes that all the process going on inside you, all the clocks you have are slowed down more and more. And if you can ultimately reach the speed of light, time will not progress at all. This is a quite bizarre idea, isn't it? Time does not progress for light at all. Light falls completely outside the realm of time. Still, it can interact with you. It interacts with you every day, everywhere. That's why you can see me, I can see you. That's why I can see beautiful colors and beautiful objects of nature. Light is a quite amazing creation of nature. I will talk about light in some of my videos, but today let's go back to time. Slowing down of time is not just a theory, it's a fact. It can be measured in laboratories even. In global positioning satellites, this slowing down of time is adjusted every day, every moment. In particle accelerators, when experiments are going on with elementary particles and when the elementary particles are accelerated up to almost equal to the speed of light, time slowed down for all of them. Another example of this is the Global Positioning Satellite, which is called GPS, which sends almost precise location from your smartphone. Those are orbiting the Earth at altitude of 20,000 kilometers from the ground, with the average speed of 14,000 kilometers per hour. And with this much speed, the time slowed down there, and this is adjusted at every moment. Otherwise, they can't send anyone your precise location. You can't have the precise location of your app cab. This is something like suppose you have a watch in your wrist and the satellite has a watch in its wrist. So the time of 1 second elapsed in your wristwatch is faster than the time of 1 second elapsed there at the satellite's watch. Imagine you are sitting on a platform and you are observing a train which is moving with a speed half of the speed of light. Then one day elapsed in that train will be equal to 1.15 days of you sitting on platform. And if the train speed increases up to 75% of the speed of light, then one day on that train will be equal to 1.5 days of you sitting on platform. And if that train is moving with the speed of 99.9999999999% the speed of light, then one day in that train will be equal to 20,000 years of you sitting on platform. So basically what I'm trying to say is time flows differently for different observers. Now how it is related to space? Now the quite obvious thing comes in our mind that how is it related to space? Space and time are woven together to form this fabric of space-time. Like different fabrics are used to produce a single piece of cloth. Similarly, space and time, they are woven together to produce this type of cloth, fabric, which is called space-time. We in our human brain perceive them differently only. Einstein called this space-time. Space and time, they continuously adjust themselves to make the ratio constant. Suppose I'm sitting here, I'm not moving in space, time will flow according to its own rhythm. I can't help that. Now, if I move through space faster and faster, then I cannot move through time faster and faster. Time has to slow down. Einstein believed that every point in the past and every point in the future is as real as the point of time we are feeling right now. Once he lost his best friend and he wrote a letter to his best friend's wife. He wrote in that letter that time is a kind of landscape. If you could place yourself in a position in the universe such that you can see the entire landscape of time with a bird's eye view, then you can see every point in past, then you can see every point in future. Then what you will find is that his friend is still alive. He is over the next hill, but we are in this hill and we are still to reach him. If we could reach the next hill, we will be able to see him. So he still exists as much as he ever has. What an amazing philosophy from a physicist. Actually, philosophy and physics are not quite different. They are just two sides of a same coin. In 1840s, the term physicist was coined. So in 1727, when Sir Isaac Newton died, he died as a natural philosopher. In fact, the book where he invented calculus, where he wrote down the principles of calculus, the name of the book was Philosophiae de Naturalis Principia Mathematica. And it is a philosophy that time is not something which just flows in front of us. We can measure it. We can measure it in train. We can measure it when we are sitting on a chair. We can measure it when we are traveling from one place to another. We can measure it in even satellites. But these are measures. And if we could reach beyond our limitations, maybe we could see space and time wrapped together all at once. Thanks for your time.